Can you see the screen? Okay, just please confirm so that we can proceed. Okay, thank you. All right, and any questions? Please let me know if you guys have any questions. Please let me know if you have any questions in any topics that we had till now. So that I can clarify them. So yesterday we were looking at the real-time jobs and the prerequisites for the real-time jobs. What are the different server level settings that has to be
Hi,
done?
sir.
Hey Lakshmi.
Sir, good morning, sir.
Good morning, Lakshmi.
Actually, you said that in flat file extraction or like that. So in that, no, while checking, you said that query also is one is there to do. Is it necessary every time to do that query also?
Lakshmi, it depends on
That's one.
scenario. So let us say if you are just taking a copy of your flat file and trying to load it into another location. So let us say this is your flat file structure and you are trying to load it from this location to this location without any changes in the structure. So in those cases, there is no need for you to have a query transformation. But let us say if you have to apply some business rules, right? Transformation rules, apply some filters, rename, change the metadata. So in all these cases, we have to go with a query transformation in between flat file to flat file. So even when you apply a query transformation between flat file to flat file, you can just select all the columns from schema in and drag and drop them to the schema out. That is one option. Without any changes, still you can use a query transformation. The second one is select your required columns from the schema in and drag and drop them to the schema out. That is a column level filter. Then go to the where tab and apply a condition saying that if this condition is satisfied, then only extract the data. That is a row level filter. Then on the schema out, select a column, go to the mapping tab, and there you can do decodes, if then else. I mean, you can do a decode, you can do a hard code, you can fill a column with a null value or a function or direct mapping from the source. So these are the different things that you can do. You can do a group by, you can do an order by using a query. So if in case you need all those things to be done, then you can go and do a query transformation in between. If you don't need it, you can directly pull the data from schema in to schema out and load it to the target.
Okay, sir. Okay,
Okay.
thank you.
So yesterday we were looking at the basic fundamentals or the prerequisites on the system, what needs to be checked and what needs to be run so that we can run the real-time jobs on data services. So what is real-time job and how do we run them? So the actual meaning of a real-time job. So just in case if oops. Okay, so just in case I created a real-time job between two tables, my source table and my target table, right? And I completed the job. Let us assume that I completed the real-time job between these two tables, and I ran the real-time job. So just in case if there are any inserts, any updates, or any deletes. So when I say insert, new records getting inserted, updates, existing records getting updated, and deletes, uh, records being lost or deleted for a particular condition. So if any of these things happen on your source table, they immediately get reflected to your target table. So yesterday we spoke about it. So it is impossible to continuously keep running a job. So what we do, we create a real-time job and then we convert that to a service and we will run the service so that the service will be up and running. Just like the services on your system, if you go to your control panel, administrative tools, and you have services. So if you go and look at the services, there are different services. Services related to the printer, services related to the Explorer, services related to more mouse, services related to the web pages, even data services. Right? So each and everything has a service at the back end, which is nothing but a job converted to a service, which keeps running continuously, right? So just in case if the service go down, you can go and restart the service. So that is how it works. So we will be converting our real-time job to a service and then run the service so that it will be continuously running. So simple question, what if I run a real-time job within my designer? So do I call it as running my service if I run my real-time job within a designer? No. So if you run a real-time job within a data services designer, it is called testing the real-time job. Just doing a simple test if it is giving required output, right? If it is syntactically correct. So all these things we will be doing that within our designer, and once we convert that into a service and then run that service, we call it as execution. So running the service is called as execution of the real-time job. So these are the two things that we need to keep in mind. So we have two sample files here. One is postcode lookup request and reply. So we need to add them to data services, and we have one source file called as request and the target file as reply. So we need to build a solution here where based on the value that is present in this request file, it has to do a lookup on the postcode and address and build the reply there. So that is what we'll be doing, and we'll be doing that in a real-time job. Then we will run this real-time job and then we will see how do we go and convert this real-time job to a service, and how can we convert that service to a WSDL. How can we invoke a WSDL using data services, but invoking will not work. That's a service pack level limitation or a bug with the current system. Right, so let me connect to data services. Right, so to create a real-time job, you need to select your project, right-click new, and you have all the legacy approaches. You can go to the project new and create a real-time job from this menu. Alright, or you can go to the jobs tab, select the real-time job and go for a new, And the simplest way is select your project, right click and go for a real-time job. So real-time job naming convention starts with RT. I'm calling it as postcode lookup. So within this real-time job, the moment I create this, it will create with the start message and an end message. So if you want to do any changes on that, so it's a fixed pattern. There's nothing that you can change. You cannot edit them. You can just move them from one place to another. That's all. Right now, create a data flow. So this is to interpret the message formats of the job. So that is the reason we'll have RT process begin and RT process ends. So TF postcode lookup is the job name. And I need to add these two files. So go to your formats tab, right click, select the XML schema, right click and click on new. Go to browse and you have two files, request and reply. Now, both are XSDs. So select the requests XSD, then give the root element name as the format name and click on OK. This file will be added to your system, the request file. Likewise, go and add your reply file. So it's a simple scenario. Request file has one postal code, which is D150LQ, and we need to pass we need to compare that with the postcode demo postcode table, and then demo address table, and get the relevant this one, the address, and build a complete reply in your target table. So now within the data flow, I will go and pull in my request file. Now remember, this is the real-time job, so make it as a message source, and reply file, drag and drop it and make it as a message target. Now click on the request file, go to the XML file test, and then so this is the request file, and if you open that and see, you'll have one single postal code. You can see it from directly from the desktop, or you click on the magnifying glass and you see it, the 150LQ. Right, so this is my request. And then for this I need to build a reply. So if you look at the target structure, it has both postcode and address, and I have to give a location where it has to be generated. So I go to my source flat file, and in the outbound I will give reply.xml and save it. Now go to your data store, select your template tables, demo address, demo postcode, right, and you have your request file. So now get address is my query transformation name. So what I need to do, connect this with this one and get the address. So what I will do, I have to get the address as an output. So the where condition that I will be giving is where the postcode from my XML file is equal to the postcode from my database table, and the postcode ID from my database table is equal to the postcode ID from my address table. So remember, for the first postal code, the postcode ID is 1, and the second postal code, the postcode ID is 2. So on the data level, here we have the second postal code, which is D150LQ. So if D150LQ is here, then the postcode ID that we have for it is 2, and for 2 we have Garden Cottages and Eaton Hall. So that is the address that we are picking here. A very simple select statement or a where condition here. Now build reply is another query transformation where we take the output from this one and connect it to your target. So click on build reply and select postcode to postcode, and even prior to that you make sure that you made it current, and then only map it. Then go to the address, right click, make it current, and map address to address. Now save this job and run this job. So there is no difference in saving and running a batch job and the real-time job, but here when you run it, you call it as enter the correct path of the nested table. Alright, so right mapping is required in the from tab. Right, the job is successfully done, and in our outbound folder we have a new file created which is reply, and if you open that, right, so for D150LQ the reply for the address is Eaton Hall and the Garden Cottages. Right, so this is how we tested a real-time job. It is just we created a real-time job and we executed that within the designer, and this is how we tested. So whatever the value that we give here, the relevant or equivalent addresses are coming out. So now this is just a job which we ran within a designer or where we checked the syntax. Now if you want to convert this into a service and keep it running so that anytime a value changes there, the relevant values get updated or affected here in the target. So you have to convert that into a service. So how to convert a real-time job into a service? So for that you need to go to your Data Services Management Console. Go to your administrator, and whatever is left when we covered the Data Services Management Console, now we'll be doing that here. So here if you expand the real time, then you have something called as real-time services. So here in the real-time services, first you need to go to the configuration tab, real-time service configuration, and here you will go and click on add a configuration. Right, already existing configurations will be displayed there. So you call it as RET underscore service 123 for unique identification, and then click on browse next to the job name. And when you click on this browse, you will see the local repositories and their jobs that are present in that one. So LR1 is our local repository, and go to it, LR1, and you have the real-time postcode lookup. So this is the job, so just click on that one, and then automatically the rest of this one this information is filled here. And if you want to give any specific system configuration, you can go and select a specific system configuration on which you want to convert this to a service. Then next one is the service provider. Just click on add. Right, so the service provider will be your job server on which this real-time jobs will run. So select that one and click on enable, and you should see enabled as yes here. Then the next step that you need to do is click on apply. So first one, give the service name, browse the right job from your local repository. When everything is good, all the remaining information is populated. If you need, you can select the system configuration and then select the server, add the server and enable it. And once it is done, you can click on apply to see your real-time service and your system configuration enabled. Now you go to your service status and you will see that in orange color. So select your service and start it. So first step, you go and convert your job into a service. Then second step, select your job or select your service and run it. So the moment you run it, it will turn into a green color to indicate that this service is up and running. So just in case if somebody says that though I do some changes on my source, they are not getting reflected on my target, then this is where you have to check first. Go to your service and cross check if your service is up and running. If not, you shut that down and restart it, right? So that is what we do. So when I say restart, you can select it and click on start. Or you want to kill a service, you can select that and click on abort, or you can completely shut it down. Right now my service or my job is converted to a service and that service is running. So this is when I executed my real-time job. So this, till the service is up and running, my job will be continuously running. So next you have something called as web services. So if you click on web services, you go to your web services configuration tab.
Hey Rakesh,
Yeah, Jafar.
I have a quick question. When
Yeah.
we have created the services, if there is any change, so we need to recreate the service, or it automatically find the latest update from the designer?
So if you mean to say you want to do the changes on the designer?
Yeah, for example, you just created the services, but for some reason, if there is any modification in the real-time job and someone modified in the designer, so do we need to change in the services, or I mean, we have to recreate, or it will be automatically replicate the changes in the designer?
So from this window, Data Services Management Console, it will automatically refresh whatever we see in that designer. But the best part is we need to kill the service first. You go here and abort the service, select your service and abort it, and then you go do the changes in the designer, save it back, and again go to the configuration, just select the same things. There's no need to do anything, you just go to your service and click on browse and select the job. Automatically the changes will be refreshed here.
So that's mean if the service is running, you cannot change it, right?
So let us say when I say my service is running, my job is running continuously. And when a job is running, technically we can't go and modify that one. So I need to stop my service, because when I say technically I can't modify this one, if somebody is waiting on that result, right? So if I go and modify something that is running, so that is not correct. So I have to kill it as per the process. You have to shut it down, go and do the changes, and again come and restart it so that the changes gets reflected here, and then you can actually have your changes applied on the service.
I got it. Thanks.
Yep. So configuration services. I don't know why this tab is not working. So the problem with this thing is whenever I teach this one and leave the system, that batch or the previous batch people will practice on this, remove all the basic settings, and do something strange that even I don't have access to do that. So let me just try showing it to you. Because the next step that we need to do is web service configuration. This is where we go and add this one, but I'm not getting an access to this tab. Alright, so this is my web services configuration tab, and if you just scroll down to the bottom, you have a small drop down here. So you need to select that and say add real-time service and click on apply. So this is the only place where we work. You just click on the drop down in that tab and select add real-time service and click on apply. Now your service will be displayed. Select that and click on add. Once you click on add, your service will be added, and here again you see your service runs on an access server which is sitting on top of a job server. So keep that in mind. So once it is added, we'll see that in the real-time status tab. So this one, we'll see it here once it is added. Yep, it is added now. So if you just refresh this one, you'll see our service that we added in the list, and then you can so this is a service that we added, which is RT serve 1234, and if you want to cross check that one, you can go to the real-time services and RT serve 123 is the name that we gave for the service. So once you see that in the list here, go to this one, drop down, and it is like 2.1. and click on View WSDL button, and it will take you to a web page. Right, so and this is your WSDL. So we have to copy this address. So okay, so again, somebody help me. How do I copy this one? The address here, the hyperlink localhost 8080. This address bar is missing. Tools, internet options, and yeah, I added as a home page, so I just copied it from here. Right, so this is my WSDL. I expose my job to a web service, and web service starts with the server name followed by 8080 data services servlet web service version 2.1 and WSDL XML. Right, so this is my web service, and now I can send it to any person who can translate this or who can convert this WSDL into a flat structure. So there are different tools like REST, SOAP, and so many other tools which can read this WSDL. So the most secure way of sending my data to the customer. So I give him a hyperlink and say you call this hyperlink into your system and you will see the data, right? So this step is called as exposing the real-time services as a WSDL, right? The next one is now data services. Can data services read something like this? So data services can provide a WSDL. We just saw this. So can data services read a WSDL? The answer is yes. So we can not only provoke but also invoke a WSDL using data services. So now how do we invoke that? So if you go to this one, so first basic server level settings, if you look at this, adapter instances, right, so we saw this adapter configurations, and if you just click on add, there are different types of adapters that are supported by data services: by design adapters, Hive adapters, HTTP adapters, JSM, Salesforce, success factors, test adapters, then web service. So web service will be the adapter on which we will be working on the current scenario, which is WSDL. So you can give an adapter instance name and add it to your system, and once you add, you should be able to see your on the right hand side you see the descriptions, what you need to fill. So once you add this, you will be able to see your description and its separate process ID, and it's started and running. So it should be up and running. If it in case you find it in orange color, you select that and click on start. So this is one server level setting that we need to cross check. And the next step that you need to do is go to your data store tab, and here create a new data store. Call it as WSDL, And this data store type is not a database, it is a web service, REST or SOAP web service, or it is just an adapter. So adapter again can be of different types. So I just gave it as a basic adapter. Then this is the job server on which this adapter is working, so that it will go and communicate with the WSDL there. And the adapter that was enabled is a web service. So I selected instance name as web service. And once you give this one, you get a provision here to give the hyperlink URL of web service. So once you give all these steps, so remember these are the steps that you need to pass on. First is give the data store name, type as adapter. Then once you click on the drop down, you'll be able to see the job server. And once you select the job server, you should be able to see the web service here. So just click on apply, then give the hyperlink and click on apply, and just make sure that there are no warnings. Then click on OK, and your adapter data store is created. Now if you expand this one, adapter data store has only functions in it, and you select the data store, right click and click on open, and you have two buttons here, external metadata and internal metadata. So cannot browse external metadata for adapter instances web services at this particular port number, root nodes XML generated so far. So I'm just taking a screenshot of this one. So there's some issue with this, so that's the reason why it's actually not running. But we should search only the external metadata. It's not the internal metadata. You should search external metadata from here. Right, so let us go and create another data store, which is ds_wsdl1, and the data store type as web service REST, and give the web service URL here. That's it, and click on apply. If there are no errors, then click on OK. So an error occurred while browsing the metadata for web service. This is the URL. Additional information. An error occurred while importing metadata. WADL document. No. So there is an issue in this version of data services. If you go and check on the previous versions, 3.0, 3.2, these work pretty fine. These web services work pretty fine on them, but from Service Pack 2 on data services DS 4.2, you have an issue with this, but I'll tell you what to do. How do we complete this process? How do we complete the process of reading a WSDL? So data services was able to create a WSDL, but it was not able to read it. So once we create this data store, you select the data store, right click and open that, and once you select on external metadata, you should be able to see something like this. So you should be able to see the service that we created under the functions. So you'll have a drop down called real-time services. So these are the screenshots of the previous version 3.x. So there will be some difference between your this one, the current screens, and this one, so don't get confused. So here we are creating a type of data store as an adapter and give the web service and give the web service URL here and click on apply and OK. And once it is done, you select your data store, right click and open. You should be able to see your data store like this. If you select on the external metadata, you'll have an a plus symbol here, which is real-time services. You click on that one, and you should be able to see the service that you created, which is RT_SERV1234. So the service that you created here, you should be able to see that one. And once you see the service, right, so RT_SERV123, so all you need to do is select that service, right click and import that. So once you import that one, you will be seeing that under your functions. So your real-time job is now, or your WSDL is imported as a function and into data services, and you should see that like this, right? So under your data store, you'll have function, and if you expand the function, you'll see your function name like this. Now next step is to create a job, right, and call that function and get the value out of that function. So I am creating a new job, so select your XML demo or the project, right click and go for a new batch job, then call it as job_invoke lookup, then create a data flow, call it as df_invoke lookup, and within that data flow you first add a row generation, because now this is a function, not a source table or a flat file. So when we don't have any source, we do what? We go with a row generation. So create a row generation and add a query transformation next to it. Then open the query transformation, and within the schema out, right? So even before that, you go to your postcode lookup request function on your data store. So you select your function, do a context menu, right click and click on open, and once you open that, you see the structure of that function here. So in that one, we need the structure of this request to do the next step. So what we need to do is we need to select this particular schema, right click and copy this one, so that we copy this request and the postcode under that. A bit of this structure we are copying it, and then go to your query transformation schema out, right click and paste it. So once you paste it, it is pasted as a nested structure on your schema out. So and also make sure that you make it current here. Select it, right click and make it current, go to the from tab and select, this is the older version, so you don't have this check boxes and drop downs here, so you can check this checkbox in the from tab of your query transformation. And once it is done, go to the mapping tab and select the postal code and give it a value DE150LQ, right? So once you give the value, then you call a structure and gave it a value. Next, add one more query transformation to your data flow, connect it with nest data and call it as invoke lookup. So this is the new query transformation name. So in that query transformation name, you remember we did a new function call. So select that one, right click and say new function call. Let me just build that job for you here, though we don't have it. Right, so you should see your function here. All you need to do is select that function, right click and import, and once you get that function, create a batch job underscore invoke lookup, then data flow underscore lookup. Open this one. Now go to your transforms tab, select a row generation transformation because you don't have a source. Then here connect it, and you need to go to your data store, and we don't have the function here. Here you just need to copy the particular structure and paste it there and give it a value D150LQ, and then go to add one more query transformation, do a new function call, and in that function call, once you click on this, you will see the functions, and on the functions on the left hand side you will see your data store name. So select that data store, and on the right side you will see the function name, which is nothing but your WSDL. You see it there. You select that one, and here there's a small trick that you need to perform. So you select that function and click on next, and next you will see this input query schema and input schema on the function. So this is the structure on your query, and this is the structure on your function. So generally what we do, we map this node to node, right? So this will not work here. You need to select this one, the schema, drag and drop it to the schema out. So you need to do it from here, but not from here to here. You can't do it from here to here. You can't drag a postcode and drop it on a postcode. You have to drag and drop it here. And once you drag and drop it here, just a blind mark, this portion will get populated. Right, once it is done, click on finish. Right, and on the schema out, you will see the function, your WSDL is calling this values. And then go to your right hand side tool palette and create a template XML file and connect it to your query transformation invoke lookup and give it the path where it has to be generated. Now once your job is done, and when you go and run your job, so this is what we will get as an output. For D150LQ, Eaton Hall and the Garden Cottages are the outputs addresses that we get. So this is how you go and call a web service using data services. So there is a bug in the version, even we wrote to SAP about this, so they are upgrading, asking us to upgrade to some other service pack where they claim to rectify it, but I haven't tried it out. But the bugs, general bugs in 4.2, your web services will not work. You cannot add an Excel file to data services designer. Right, so if you just go and add something Excel file, it will say access directory or access database is not properly installed. And the reason that SAP gave for it is if your data services is installed on a 64-bit machine, and right, it says Microsoft Access Database is not, engine is not installed properly. So the reason SAP gave for that is your data services is 64-bit and the MS Office on your system is 32-bit. So please upgrade to 64-bit and it should work. That's the SAP note given for that. And apart from that, this WSDL is again invoking a web services. Again, a small minor bug, because these are not the major bugs that SAP has to take a step on it. If not, the tool will be collapsed. No, on a very rare situation, you get some customers who will be working with WSDLs, right? 90% won't. Remaining 10% they will, because they have a defined process and they believe in some guy who gave the solution, so they wanted to run it that way. So in those cases, you might get these WSDLs, XML data, and if we get them, this is how we prepared our, right? So any questions on this one? Any questions on the topics that we covered so far, because we are almost coming to an end of our training. So if you have any questions, please utilize the time and let me know so that I can clarify them.
Sir,
Yeah, Lakshmi.
you are saying in about real-time job right now. So the real-time job completed only when I do all this like up to the end till web service configuration, web services, and all.
Yeah, yeah. So once it is done, you will be doing all those things.
That is like if the real-time job is run, then after that the job is completed only after I do the web services also. You have explained the web services.
Yeah, so when you run a real-time job within your data services designer, it is not running your job, but this is just testing your job. So when you run a real-time job within your data services, it is not called executing the real-time job. It is just you're testing the syntax of the job, right? So you will test it, and then if it is good, you will convert that job into a service, and then from that service you will run the service, and then you pass it to your web services and convert it into a WSDL. That's the process. So running it is just testing it here within your data services designer, but if you go and run it from here, once you select this one and click on start, so that is the moment where you start your services, which means you are running your actual real-time job.
Okay, sir.
Yeah. Alright, so next, let us go to the next step, or next part of our training, which is an introduction to HANA Studio, and then we will go and look at how do we load data from data services to HANA. So I'm just opening all the architecture images that I find on the internet, and I'll just walk you through this one. Right, so this is just on the HANA level, right? So what are the different tools that we interact with HANA, and how do we project data out of HANA? So before I say that, so let us say what is the need for HANA, right? So down the lane 2007, when I was in SAP BI, 2000, not even 7, it's 2005 or 2006. When I was working on SAP BI, I just heard some rumors about SAP stopping its support to Oracle. So why SAP has to stop its support to Oracle? So if you look at this SAP systems, right, SAP applications, so this application, this is just an application which runs on a database. So this database can be a DB2 or an Oracle. Generally these two. So whenever SAP is selling its application, or SAP is making a customer, then SAP is maintaining this customer, or maintaining an existing customer, not only a new customer but also maintaining an existing customer. SAP is doing almost 60% of Oracle sales by selling its database licenses. Because SAP is just an application which needs a backend database, and it should live on a database. It is just an application. So SAP is selling Oracle, though being a key competitor with SAP is directly selling the Oracle licenses. So they said that they will come up with their own, you know, own database, and which will be not a general database. So that is what a rumor that I heard long back. And then that rumor came to reality where SAP came up with SAP HANA, right? So SAP acquired so many tools. So if you know them, some of them are Sybase, right? So some other databases. SAP acquired business objects, right? So there are so many acquisitions that are done by SAP, and Sybase is in-memory database. So that maintains the entire data within the system cache. So if you look at the architecture of this one, so this, let us say this is my Sybase system and the backend database. So whatever the data that you have within your database is completely maintained within your system cache as well. Right, the entire data is maintained within your system cache. So it is called as in-memory database. Right, so a little more advanced and fine-tuning work was done on that, and it is also called as in-memory calculation engine. So which is in-memory calculation engine? Our SAP HANA is our in-memory calculation engine, which maintains the entire data within your system cache, not only maintaining the data, but also it will give you some key calculation features, right? So that is your HANA system. So the general marketing strategy of SAP, when it was trying to, project HANA, it said like, if a customer swipes his credit card on a machine, a swiping card, and the fraction of second that it takes to swipe his card is the time that should be enough for anybody to get the entire information about this guy. So why he needs something? How can he get the data pretty fast? Because it's an accelerated database. It is not just a change on the application. It is not just a change on the functions or features of SAP HANA. It is also an accelerated database. So if you look at the database, just do this exercise. So just go to Google. That's the best exercise that we can learn something. So if you just look at the server, so there are different sizes of servers based on the customer requirement, and if you also look at the servers, there will be multiple scale up and design. This is a bit advanced to talk about. I'm sorry I haven't kept them ready. Right, so yeah, so these are the different sizes: small, medium, large, and large plus and large plus plus HANA servers that are available. And if you look at a server, it is not just a CPU, right? Multiple boards per stack and multiple RAM slots on that one. So it is an accelerated system. The hardware itself is completely accelerated. So now if you look at this one, this is one rack that you insert, and on top of this rack you again have multiple RAM slots. So all together, so look at the RAM, size of the RAM, it's like 250 GB per blade and 512 GB per 2 blades, 1024 GB for 4 blades, 2048 GB for 4 blades, and 4096 for 4 blades. So for 4 blade server, this is the cache that you have on your system, 4096 GB, right? So you'll have the entire data saying on it. So this is an accelerated system, or because of this one, the application on top of it will also run fast. So if you look at this HANA system, so you have two components there. One is your HANA database, which is an accelerated system, and on top of that you will have one more application called as HANA Studio. So these two are different. Right, so HANA Studio is something that we install on our system, and somebody talks about the architecture, they talk about this one but not this one, right? So HANA Studio is a front-end tool that we install on our system, and if you go and look at the architecture, so we have different diagrams on the architecture, how this works, and what are the different provisioning mechanisms and the server size, right? So these are the features that I was talking about. So multi-core processing, right? So parallelization and multiple cores per system, then dynamic multi-threading, virtual aggregates, partitioning, then minimal projections, right? No disk operations, only inserts, no updates and deletes, then real-time replication, any attribute as an index. So you can use any attribute as an index, because the data gets stored in a HANA system as column stores. So there are two types of store: the row store, which is a generic one, the way our database tables get stored, and second one is a column store. So if I have values in a column, so it's not a row, in a column, department numbers, like first row I have 10, second row I have 20, third row I have 30, then again fourth row I have 10, fifth row again 20. So if I do a column store on this department number column, I will have values 10, 20, 30 and 40. I will not have the repeated values. And the relationship between the rows and these unique values stored as a tuple will be maintained in the backend algorithm tables. So these are the different features on the HANA system, in-memory database or the server. So you don't have aggregation, so that improves the performance because your data is already saved in the column store. So all these features, like on the software side and on the hardware side, they will give you a much accelerated performance. And if you look at this architecture, if, like as I told you, somebody talks about the architecture, they're talking about majorly the HANA database, and HANA Studio is a part of your architecture. So it's not HANA Studio, please don't get confused with that one. And now let us go and look at the architecture here. So even before we talk about the architecture, so there are two ways in which SAP HANA can be used, right? So one is as an appliance, right? So appliance, when you say an appliance, you build a solution on SAP HANA and give it to the customer. So when you build an application or a solution on an SAP system and HANA system and give it to the customer, so that customer will be called as powered by HANA. So if you listen to the words Saint Gobain powered by HANA, Colgate Palmolive are powered by HANA. So if you listen to those kind of terminology, you remember that they had made their applications on HANA and they are using HANA as an appliance. The second one is HANA as a database. So remember the diagram, we're talking about an ECC application on top of, or SAP system on top of a database. Now the second thing that we do is you replace that database and use SAP HANA database as a backend database, so that the entire data will be in an accelerated mode and you can read the data pretty fast from this one. So SAP BI, it's also a database, right? You save the multi-dimensional data in SAP BI, but why it is not that click? Because in SAP BI system, the data that you see yesterday's data on an ECC system. So you have 1 day's old data. So they also did some R&D on the tool. They created some BI accelerators, some pedals where you can press them, and a portion of your data is like called into your system cache directly from ECC, or a portion of your data is called into your BI system cache directly from ECC, and that can be utilized. So that is one way in which they did a promotion of data partially, but not the entire data. But now if you go and replace that backend database with SAP HANA, then your entire data is accelerated. Whatever you need, you have it in cache. So just remember, something is in your system cache, and pulling that compared to writing a query on a database from 10 tables, join them and get the data from the 20th table. So that is a risky thing and a resource consuming and also a time consuming activity. But if you have everything in your system cache, that will be pretty fast to access. So if you look at this, so sorry, so HANA Client and HANA Studio. The Studio is a designer where you can go and create some models on your data and then project it to the customer. So let us say my data is loaded into SAP HANA database, and I connect on top of SAP HANA database, I connect with my HANA Studio, and here I see the data that is present here. Now let us say I strongly believe that the data that is present here in this pattern, I cannot directly give it to the customer. I have to put it, polish it, and create some models on top of it, and then I can give it to the customer. If I feel so, I can do 3 types of models. Call them as attribute view, then analytical view, and the third one is calculated view or calculation view. So these are the 3 sorry, bad throat. So these are the 3 data models that we create on top of the data. We create an attribute level display, or we create, this is a 2-dimensional, this is a multi-dimensional, and this is one more dimension on top of multi-dimensional, where you project a particular portion. You call this as projections. So you can, in a calculation view, you can do 2 mechanisms again. I'm just giving you a heads up so that we can just also talk about this one. So you can do 2 types of projections in calculation view. One is SQL and the second one is graphical. So if you are good at SQL, you can go and write a backend SQL code for the calculation view. If not, you can go and do a graphical representation. Just drag and drop and customize that, and you can see that in this one. So this is your HANA Studio, and once you create these views, you will project them to the reporting layer. Right, you will project them to the reporting layer, so you can directly access the database table that is here, right, on the HANA Studio, and then your views that we created on HANA Studio, and then project them to the reporting. So if somebody's from a database background, so directly compare it to your Oracle database. So you'll have some schema, and under that schema you will have some tables, and you don't want the entire table to be called when your query is executed or when your report is refreshed. What we will do, we'll go and create some views on top of it, right? View 1, view 2, view 3, however it is required for the other guy. So we'll create the views 1, 2, 3, and then we can use these views or tables however it is required in my reporting layer. The same work I'll be doing in my HANA Studio. right? I connect to the backend database and my data is displayed under a schema here. So now I'll go and create some views. So on a database side, you just go and create a view statement saying that create view. So you can create a forced view or you can create a normal view and say that create view name as select star from the database table name, and your view will be created with all the columns that are on the database. But you don't want all the columns, you want selected columns. So you create a view statement saying create view, view name as table1 dot field 1, table2 dot field 2, and so on. Give the column names and then use where condition if you are joining two views or two tables, then you'll get the data out of it. The same thing we are doing here on an attribute level, on an analytical level, and on a calculated level, and we'll be projecting that to the reporting layer. So this is about your entire HANA, your backend database where your accelerated data is saved, the studio where you can either look at the direct tables, create some views and models on top of it, and you can give it to your reporting layer, which can be your business objects reporting layer. If you look at this, so business objects tools, SQLs, BIX, MDX, these feed to the business objects tools. And even if you install an Excel on top of the HANA server, so it will get with an additional connectivity. So you'll have some add-ons here, data, and if you just go to that one, you'll have an add-on connection to the HANA Studio. There you need to give the HANA server username and password, and that will allow you to connect directly to your HANA database, and you can pull some data from your HANA and put it on your Excel. And Excel is like the age-old reporting tool that was used and that will be used. So they pull some data into Excel and again do this. So if you look at this one on the HANA database, so you have real-time data replication, business objects data services, then you have in-memory database where you have calculation and planning engine, row and column storage, and then computing studio, in-memory computing studio. So this green stuff is my entire HANA box. So in the HANA box, there are different types of replication mechanisms or data provisioning mechanisms. One is your real-time data replication, also called as your SLT, which stands for System Landscape Transformation, and that is done by the SAP. So that is an inbuilt tool on the SAP side. So people from SAP, that will be installed on top of a NetWeaver stack. So first you need to have a NetWeaver. So if you have a system which is already with the NetWeaver stack, so you can go and directly install your SLT on top of it, or if you don't have a NetWeaver stack, you can have a separate server with a NetWeaver stack on top of it, and you can install an SLT, and this SLT will handle the real-time replication. We'll look at the diagram in a bit later. Then the second one, the extraction mechanism or data provisioning mechanism, is using data services. So these are the two major things. One is your SLT and data services. So let us talk about the differences. So these are my backend data sources. On top of that, these are my data provisioning mechanisms, and once I load data to HANA using these two tools, what are the different things that I can do in HANA? And once I do that, what I can do in my studio and how I can give it to my target system. So this is the layered approach. This is my database layer. This is my data replication layer. This is my HANA database layer, and this is my studio, and these are my reporting tools. So how I can handle this, all these things you can see here. So the major difference between SLT and bots. So SLT is limited to SAP systems. SLT stands for System Landscape Transformation. So when I say system landscape transformation, the entire system landscape can be transformed from your source to your target. So in this SLD case, your source will be your SAP system and your target will be your HANA database. So SLT works with the SAP Business Suite. So you can connect to your ECC system using SLT, pull the data. So this is how it works. So from ECC to SLT, it works on RFC connection, and from SLT to HANA database, it works on DB connection. So it pulls the data from here to SLT, LT replication server, landscape transformation replication server, and then it loads to the HANA. And sorry, that is only for SAP systems. It is not for a non-SAP system. So what if your customer has both SAP and non-SAP systems? This is where we go and sell our data services, right? So data services can connect to both SAP and non-SAP systems and then pull the data to the HANA Studio, HANA database. The second major difference, there is no much space for you to create some business rules and transformation rules in LT replication mechanism, right? So you just take the entire landscape, dump it into the HANA system. But here on the data services side, you get a lot of provisions. So there is like entire space for you to do data transformation. You can do conversions on the data. You can do manipulations on the metadata. You can do manipulations on the data. You can do lookups, validations, so whatnot. We read everything about that, and whatever we read, we can do between your source and HANA database, right? So once it gets into the HANA, so you also see different mechanisms here. Okay. Right, so bad pictures, but you can just, data provisioning with SAP HANA 1.0. If you just search for this, so you'll get these things. So we have these sources. So SLT is SAP Landscape Transformation is one. So then we have DXCs, direct extract connectors. So this is really bad. So ETL services, you see something here. So this is using data services. You can load it to your HANA system using ODBC connections. Then log-based replication mechanism. So initially Sybase. So if you know Sybase works on log-based replication mechanism. So they'll take the entire logs and put them on the target. So the system logs will generate the data on the target system too. So that was ruled out from the version 1.0. So then extractors, so DXCs, direct extract connectors. So if you have an extract structure and communication structure, you can directly pull them using this extract structures, and you can load them to the target HANA database. And this is some real-time services. I don't see it properly. So this real-time services again load the data into HANA system. So there are different mechanisms in which you load it. One is your SLT, the second is your bots, the third one is your log-based replication, extractors, and this is something new. Direct services to do a real-time job into your SAP HANA Studio. Right. So in these all mechanisms, the major ones that you see here is your real-time replication and your BODS. So using those two mechanisms, we'll be loading the data into the HANA Studio. And if you don't have much transformations on the data, you want to take it a dump from your source SAP and load it into your target HANA, then you can go with system landscape transformation. And apart from that, you want to do a lot of validations, transformations, enhancements, enrichment on the data, you can go with bots. So once you load these data into the HANA database using any of this, so when I say HANA database, it will not reside on the physical drive, but it resides on your system cache, it resides on your memory. So that is the entire data, as you store it, it is your accelerated data. And there are two mechanisms while you store your data into the HANA system. One is your row store and the second one is your column store. So row store is something very natural, the data that we have. So if I have something like employee number, name, salary, department, so if we have something like this, salary 10K and department 10, then so this is the general row store where I see the data in table and row format. But if it is a column store, if I did it a store on a column wise, so it will go and pick what the unique values, 10,000, 2,000, 3,000, it will keep them, 3 different names, it will keep them. And now it will not keep these values. What it will do is it will give 10K and 20K. And the relationship is maintained in the backend algorithm tables. Again, here on the departments, it will give 10 and 20. So there is no aggregation required at the database level. And the second thing is I am saving a lot of space by not posting the unwanted data, just maintaining the relationship in some backend logical table. So this is pretty fast. So this is what you call as a column store. So you pick the unique values and put them in columns, and this is your column store. And the relationship is maintained in the backend tables. So that is what we see here. And also you have the calculation and planning engines. So once you store the data, you can directly give the data to the target system as the data. So let me tell you the advantage. As the data is already stored on your system cache, right? It's not on your persistent drive or it's not on your disk drive, it is on your RAM, it is on your system temp space. So as it is already available, so the data, if anybody writes a query on top of it, it will just give the data like that. It will give it pretty fast to your target reporting tools. And on that data, if you want to create some calculations and models, so you can use this planning engine and calculation engine that will help you to do. So if there will be further steps, like if you look at this one, so here I'll get back to this one a little later, probably tomorrow we'll talk about it. So calculation engine will help you to do a lot of calculation activities, right? So you see it here, SQL script, parser. So let me tell you this. So if somebody writes a query on top of this one, so it will first go to the SQL, and SQL parses it into small subqueries, and those subqueries will be executed, and then it goes to the calculation engine if some calculations are required, and then through MDX it goes out of the system. So request processing or execution control is handled by this box. So that is what we are doing here. Alright, so that is on your database, and then you go to your HANA Studio, you connect to your database, and in your HANA Studio you go and do your data models. You create your attribute views, analytical views, and calculation views. You project that data to your target system. Let it be a reporting tool, let it be a universe, so whatever it is. So you give the data in the design model to the target system, and they can refresh it. Now compare a report refreshing on a database to that on a system cache So system cache will run pretty fast, because if it is general a persistence layer or a database layer, I'm just giving you an example here. So if it is your database or a persistence layer, and this is your system cache, and on top of it if you have a report. So generally what happens when I refresh or execute the report, it goes through my system, and the system points back to my database. The database sends the response to my system, and from here it utilizes the cache and goes to the report, right? But how about a system which has the entire data only in the system cache, right? And I'm just running a report on top of it. So it is as good as the data is already there in the report, right? So this is the difference. So you cut off one layer, and you directly have the data in the system cache, and that is how quick it gets refreshed. So that's a little introduction to HANA Studio. More theatrical. What is HANA? Why it came into picture? What HANA can do? What is SLT? What is bots? What is HANA database? And on top of it, what is Computing Studio? So we will look in more details. We'll look about this diagram, what different layer does here. So this is a theory. Even if you go and join a HANA session, they'll talk 2 to 3 days about this, and then they will go into the HANA Studio, show you how to create models. So we'll cover most of it. So if you can do a little more hard work and gather some documents online and read it, I guess there will be no need for you to go and do a HANA training again. So I just felt like I should talk about it, because going forward, that is the future scope. You'll be loading the data into HANA. So tomorrow we talk about this architecture. I'll also give you a little heads up on S4 HANA, the recent one. So what is that, and what is the vision? So though it is an imaginary mission right now, so what is the vision on that system? We'll talk about it, and then we will go and do a data provisioning. Like we will create a data store between HANA database and data services, then load the data. Then after that, we'll go and connect to the HANA Studio. So I was just trying to connect, but some connection issues were there on the HANA Studio. So let's go and create those connections again tomorrow. And once the connections are done, we'll load the data to HANA database, then go into your HANA Studio and do a sample view on the data. So we'll complete the data provisioning mechanism as well. That will probably take some 15 to 20 minutes, and after that we'll start with the project orientation. Once we are done with this one, and the rest 1 hour we'll spend on the project orientation, we'll just cover the theory part, the fundamentals of what we do, the methodologies and all these things. And once we are done, I'll walk you in details steps to my project, and I'll explain you what we have done on that project level, right? So another 3 sessions mostly, right, or 2 sessions to go depending on how we accept that one. So let's go ahead. Right. So any questions on whatever we discussed today? So let it be about HANA Studio, HANA database, data provisioning mechanisms, or real-time jobs, web services. Any questions, please go ahead and shoot them. Yeah, so when we create a data store, Sandeep, your question, we can connect to SAP application as a data store and data services, which has HANA as a database. So, so you are saying that if your SAP application is powered by HANA backend database, then you can directly connect to your application. So as of now, we haven't got those systems as of now. Only the BI system is supported by HANA, and that too they are going by finance module. FICO is supported. They are working on logistics now. So the entire landscape, the vision of SAP is not yet come into picture. So once it is done, then you directly connect to the SAP application, and if it has a backend HANA database, it will work. Or you can directly connect to your HANA database and load the data using data services. Yeah, Bhargav, to tell you frankly, I had a call right after our session, and it went on till 12 in the noon, and then I had to rush to office and take some other calls, so I did not get time to look at that. But let me do it today, and once I go through them, I'll see if the documents that I have are more meaningful, or then I'll walk you through that one, or if I find some information on the documents that you share, so I'll also walk you. I think you shared me the TFS, right? Technical and functional specification. So let me go through them, and as required, I will walk you through them as well. So yep. So guys, thanks for your time, and really appreciate this batch. It's been quite interactive, and yes, Jaffer. So as I told you, I just bumped into another call right after this meeting is done, and I had a very long day yesterday. I could not send it to you, but yeah, so I will send it today. Once the session is done, I also need to sit with our basis guy and figure out the connection to the HANA Studio. So once it is done, as I'm doing it, I'll be sending you the materials or whatever the documents that I have on this one, the PPDMs, the RDSS. I'll share those things with you guys, so you can just look at them if you get time. Just look at them and be prepared for tomorrow's session, so that it will be, you prepare a bit on that one, and I just navigate you through that. It will be pretty easy for both of us to cover that fast, right? So once again, thank you, and have a good night and good day. We'll catch up tomorrow.